Okay, well, we have a lot of people here. A lot of things to talk about. I'm going to try to this just as brief as possible. We got some interesting structural settings to try to get us tap as much knowledge and experience and ideas out of the panelists as possible, and maybe also leave some time for your questions. Funny story, when I started working at OpenDP 10 years ago, people said, oh, there are these CS theorists that we got a grant with, go talk to them. And I went and talked to them and they say, hey, we've proved all these theorems, why isn't anybody using it yet? Like, we know how to do counting queries, why aren't you statisticians using DP? And so fast forward to today, and you could ask the same question, which is, you know, TPDP, most of us were there, it's really, really fascinating, an enormous explosion in the number of things we can do in DP things. The enormous consequent explosion in DP being deployed in industry, starting to see, but maybe you can still sort of, at some level, lots of people here have done phenomenally interesting deployments, but we could still say, or we could say with OpenDP, wow, look at all the things that we proved, why aren't we using it yet? So, the purpose of this panel is talk about how hard it is to get DP in deployment, in action, DP in motion. That's the name that Michael gave us. Want to talk about what are those bottlenecks, because sometimes the bottlenecks of practical deployments are not necessarily the things we're solving with researchers, or the things we're aware of if we're privacy advocates, or the things that we're thinking about if we are data collectors, those kinds of things. So I have a really talented panel. If this was a panel of like the cool DP applications that exist, it could be the same panelists. But the choice here has been not to have people talk about all the things they've done, because that would just fill up all the time, is to draw on their experience in terms of what is it that are still the open or challenging questions for getting deployments in the future. If you want to know who these people are, what are you doing here? Because you should know these people. But there are bios online, and we are going to skip that sort of first 15 minutes of people introducing themselves. What I will say is everybody here, who many of you are familiar with, are all researchers in privacy that are working in industry or working in practical deployments, and also wear therefore many hats. So everybody here is a privacy researcher, but also is some cases a product manager or a privacy a VP or a CEO of somebody, and somebody trying to get an engineering manager running a group, trying to get something, doing all those hats too, and it might be part of this discussion. So I'm going to start off online. We have Peter Cruz from Google, and Sarah Cradle's joining us, who will talk about straddling both worlds, both as her academic work and her industry work at Meta. Live and in person with us. A lot of people have flown a lot of distance, so thank you. Andrew, it might be a record. I'm not sure who's flown the furthest, but Andrew Knox from Decentric has come from the Netherlands. Olivia from Gretel has come from
Washington, D.C.
Huh? Okay. Tammy has come from Open most recently. Okay. And Jerome as well from Tumult. Sorry, I've forgotten names. And them and so to start off with. The fundamental question that I was trying to set this up with as succinctly as possible and failed is what are the pain points? What are the unsolved things that make creating a DP implementation in industry, make it hard for industry to adopt DP in practice? Let's start off online. Peter, you have been. You should know that you're the first person to respond, and then I'll follow through with others.
Sounds good. Okay, thanks a lot for inviting me. So there are still a lot of pain points despite all the progress that we've made, and I do want to emphasize that we've come a long way, and we've made some pretty big deployments, especially at Google, but across the industry. But let's focus on the pain points. So a lot of times we go talk to teams, and the first thing they tell us is, why do we want to actually adopt DP? What's the point? Is someone going to force us? Is a VP going to force us? Is the CEO going to force us? It's still very unclear whether or not DP is necessary to kind of satisfy the requirement of any law. We bring up a lot of things from GDPR to DMA to all sorts of laws that are popping up. And these are just interpretations from people that, oh, if you actually adopt DP, this can help with such and such. But there still is not any clear text around, if you don't use DP or something equivalent to DP, something bad will happen. You're breaking some law or regulation. And therefore, teams always push back against it because it's going to introduce noise and hurt the accuracy of their statistics and metrics. And it's unclear to them why they need to use it. So that still, I think, remains one of the big pain points. And hopefully in this panel, we're going to touch on what can we do on this front so that we increase adoption. The other thing is explaining DP has become much, much easier, but it remains challenging to some people who are seeing it for the first time. It's not the easiest thing to understand. There are operational interpretations of it. You can explain it as a binary hypothesis test, but people tend to think of memorization as something they'd like to protect against. And if you're training a machine learning model, explaining things like membership inference attacks, which are equivalent to DP, is a lot trickier than explaining things like, I don't want the model to spit out something that personal that I've typed on my own keyboard. And so there still is a gap in terms of what operationally people might want to protect against from what DP is actually trying to protect against. The choice of the DP epsilon remains a big challenge. We try to achieve something in the low single digits, as close as possible to 1, if not smaller than 1. And it's funny because a lot of people tell me, you work at Google, you have billions of users, so it should be very easy to achieve the epsilon of 1. But little do they know that a lot of the apps that we have, even though they have billions of users, take Gboard for example, it has, I don't know, maybe 2 billion users today, but for some of the languages like German or other niche languages, they don't have anything or close to millions of users of that language. So we end up with much smaller populations, and it's difficult to achieve these small epsilons. And so we're looking into ways around using public data, and it's also a big open challenge on kind of how do you combine public data? What is public data? Is anything on the web truly public or not? And how do you process it and use it and combine it to improve the accuracy and be able to achieve these smaller epsilons? The hyperparameter DP mechanism.
Not fostering community. So thanks. Jerome McLeod is CEO of Tumult. Peter, sorry, I really thought your sentence was finished. That's is CEO of Tumult. You want to follow on from that without insulting the rest of Europe?
I'll try. Can people hear me okay? Okay, yeah, thanks. Thanks for having me on the panel. Yeah, I agree with the top level message that Peter said, which is that there's a lot of pain points, but we have come a long way, and I think it's worth noting that the existence of libraries, like when the theorist came to you and said why people are not using it, that was maybe 5 years ago, right? And now in the past couple months, I've read 2 or 3 papers that are doing comparative studies of open source DP libraries and critiquing them. And I think that's an amazing achievement, and things are going to move really fast now. And it's a huge thing that convinces others that the technology is ready for prime time. However, there are lots of pain points, and we have a lot of work to do. And at Tumult, we help institutions. I think there's a distinction between institutions like Google and other institutions that are not as technically, savvy when it comes to adoption. So what we think a lot about is how do we help government agencies and other institutions, let's say insurance companies or companies in retail and finance, adopt this brand new technology. And sitting there with a DP library that represents the core engine that allows you to do DP computation is, of course, an important first step. But going from there to successful deployment requires a ton of hard things that most people at these institutions are not going to be able to do alone. And so we think a lot about the kind of curve of adoption, and most of the time when you have a new user trying to adopt this technology, they're thinking about just demonstrating the feasibility of differential privacy for their problem. You know, is this going to let me use data the way that I want to? How is this going to, you know, let me sleep well at night as it pertains to privacy risk? How is this going to let me make good decisions about privacy risk? And an engine alone does not do those things. So I think we need to create, you know, tools, and not just tools, but also practices and support for users to get first to successful pilots of the technology. And you know, that means not having to enter, you know, bewildering choices of parameters like privacy units, clamping bounds and stuff like that, but also tools and support for navigating the essential trade-offs between privacy and accuracy, and tools and support for communicating what the privacy guarantee means within their institution. And that's just to get to a pilot. And what we really want to move these institutions to is beyond a successful pilot to kind of institutional uptake of this technology, so that they're spreading around the institution and that there's kind of norms and standards so that new data products can be created, you know, easily. And so that's a whole workflow of other tools and support that people need, including you know, monitoring ongoing uses of different privacy within an institution, and, you know, managing privacy loss accounting across multiple data products. I mean, but ultimately, I think the theme is that we need to get, you know, new adopters of differential privacy to see the value as quickly as possible, and it takes, you know, months and years and lots of effort sometimes for a new adopter of differential privacy to get to that today.
Out of order here, which is the order that people sat in, but Lipika Ramaswamy is research scientist and product manager at Critical AI. You no longer have to be a product manager. It's like a promotion only, right? What would you like to add?
One of the things that I've seen a lot of is, what is an epsilon of one actually? Like practically, what does it actually mean? Yes, there is the probability definition, and you can sort of show people what the equation looks like. But practically, if there's someone who's sitting and saying, okay, I have $1 million to spend, do I want to spend it with an epsilon of 1? Do I want to spend it with an epsilon of 8? How do I make that decision? What is good enough? And how does it fit into the regulatory framework? And so that sort of very broad question, I think, directs a lot of funding. And then the lack of an answer to that question that's satisfactory to someone who's sitting at that level can also mean that things don't get deployed quite at the cadence that you would hope after having done all the work of demonstrating that a DP algorithm is actually successful in a certain case. So there have been some good papers on what does epsilon actually mean, like what does this mean with relation to adversarial attacks? What does it mean in the probability space? Are there different ways that we can explain it to folks who have potentially different backgrounds and come from slightly different quantitative areas? So I think that is also quite open, and honestly, it just requires a lot of targeted work in specific industries too, with the requirements. And something like healthcare, where you're studying a rare disease and your population is really small, versus, you know, you have just like tons and tons of data that you accidentally collected. Now what do you do with it? When you're working with different scales of data, also the interpretation, or rather the argument that has to be made for using a specific value changes.
Tammy Grisby is Vice President of Engineering at Anonym. Do you want to add anything?
Yeah, so maybe just reiterate a lot of what was said of the lack of understanding makes it really hard to talk about privacy with stakeholders. And if, you know, especially maybe not in my current role, but in previous roles at companies that were smaller and didn't have as much technical expertise, it was a lot easier to go to a broad group of people and talk about, well, I'm just going to create groups of 1,000 or 10,000 and we're going to create privacy that way, rather than trying to explain concepts like differential privacy. So finding ways to explain it that is more approachable, I think would help a lot. And then on the other side, I think helping novice DP implementers, I'm not even sure what the right vocabulary would be, learn how to implement the tools correctly. Right, I think back to, I'm gonna date myself, the early days of ML. Scikit-learn first came out, and I remember a researcher coming to me and was like, I got this phenomenal AUC, it's like 0.99999. It's like, I'm pretty sure your feature or your label and you're actually at your feature set. Right, it was very easy to help debug the mistake that was made to help them get the correct implementation. It's not as easy with differential privacy to make sure that your implementation is correct. And so the more tools we can create to help people learn how to use the tools, I think also help with adoption.
Great, I'm gonna sort of a follow-on question here, which is that, so these are things that are being pointed out. Academic researchers, many of those in the audience and our colleagues at TPDP and other places, they generally want to translate the innovations that they're working on into real-world impact. We all want our things to be used. The puzzles that we're interested in are often very, very practical, but don't necessarily understand which problems are relevant to go out and solve, or which are the ones we should be spending our time on. We might know which papers can get into ICML, but we might not know which ones would, get into a code base. So understanding which problems are relevant, what constraints practical deployments face is not something that we sort of highlight in the research community. Sarah Trable's here, who's traveled both worlds and worked on that, as many others have here. Sort of a follow-on, if there are all these pain points, what are the mechanisms that you've seen that you think are useful in trying to increase communication or highlight industry problems and get that into the academic research community, Sarah?
Yeah, so I think as far as the mechanisms for getting information from industry to academia, I actually don't necessarily have that much insight on the specific mechanisms, but I do think that that industry has been doing a lot of trying to publicize, like, here are all the cool things that we're doing. And a lot of that is sort of, it serves a function of trying to put pressure on other people in industry or trying to, elevate your company above others because, like, we're doing cooler stuff. But a lot of that literature is framed for people who maybe have heard of DP or haven't heard of DP, but people who aren't experts. And so I do think that there's definitely room for some type of blog that is industry communicating with academics who already know what DP is. I think that the most important type of communication that isn't really happening is clarification on how the setting that industry is working in does not line up with the super clean model of what differential privacy is. And I think differential privacy is so inherently worst case that is almost, the techniques of differential privacy are very practically useful for scale versions of privacy protection where you're wanting to practically protect the data that you're working with. But there is a sense in which the worst caseness is a bit overkill. And so what you're seeing in industry is a lot of somewhat ad hoc, sensible, but ad hoc ways of saying, well, let's kind of relax this a little bit. And so I think that academics could really benefit from clarity from industry. And this is what our data looks like. This is our analysis pipeline. And here are some additional constraints. We can't hold on to data for longer than this. And a really important constraint is that oftentimes you get a piece of data from somebody and you don't know if that somebody is the same as the piece of data you got a week ago. And so that really can't be captured in the super clean model of differential privacy that academics are using. Academics have a long history in differential privacy of putting forward new privacy relaxations that are good for one thing versus another. It seems like there haven't been very many relaxations that say, we're actually not going to give an exactly worst case guarantee, but here's the nature of the guarantee and we can still make it rigorous. And I think that can really elevate the types of techniques that practitioners are looking at.
Great. Peter, you've worked in that space too. Jerome, you straddled both the academic world and the industry world. Are there any things you wanted to add in terms of how you foster research engagement on the kinds of problems you actually face in deployments?
Yeah, so just very quickly, I want to say that we've had a lot of success with putting out manuscripts online where, we bring a bunch of academics and a bunch of industry folks, sit down together, and we write a set of open problems or interesting open questions. And we've observed over the past few years that those manuscripts are not just well read and cited, they led to research kind of that builds on some of the open questions that we discussed. And they changed the way people view some of these problems. And as Sarah was just saying, like, we inform them about the constraints, the practical constraints, and some of the parameters that we want them to focus on when designing algorithms. So I think that plus workshops, having industry hosted workshops, both in academic conferences or invited type workshops, helped a lot.
Yeah, I'll just quickly add, I think it's an important question. I think definitely we need more science to be deployed on practical problems that we're trying to tackle. I think it's really helpful for academics if people doing deployments can publish the details. Like you said, the requirements of the problem are as important as the solutions. I think the public sector has done, Census Bureau did a reasonably good job of really laying out the problems that, some of the problems that they solved at least. I think the private sector, there's lots of deployments we hear nothing about and we'll never be able to learn from, which is unfortunate. I'll just mention one concrete thing that we have done at Tumult is post open problem posts on differentialprivacy.org. Recently, we posted 2 of them. These are open problems derived directly from the work we're doing with deployments, and we got some good response. We got both academics and industry folks, kind of talking about the problems, and it'd be great, and we appreciate that input, and great if others did that.
That's great, and I'll try to make sure that Sharon posts a link to that. And then also Peter mentioned, like, there's a recent April paper from a workshop that is Google, Meta, Tumult, and others. What are the open problems there? Microsoft is thinking that. We've talked about the problems of deploying DP as if DP is a sufficient cure-all standalone end-to-end privacy solution. But sometimes deployments in practice also require understanding a larger threat model. There are other pets, right? This is the DP week in Boston, I realize. So I want to talk about the way that often we're trying to solve an end-to-end privacy problem by combining both the output privacy of DP with the security and privacy consideration advantages we can get from other pets. I think that's an important thing that we sometimes lose track of. Or one that's gotten a lot of focus recently is deploying DP solutions inside either clean rooms or trusted execution environments. There's 2 people here who got a lot of experience with that, and then others who want to talk about other combinations of pets. So we'll start off with Tammy.
Maybe just take a quick survey. How many people in the room feel like, yes, I know what a trust execution environment is? Okay, like half, so pretty good. So I'll give a quick summary. When I think about computation and secure computation specifically, I think of it as a spectrum. I don't know, on my left is maybe the shared server we used in grad school where I can access everyone's data and code, and it was great for collaboration, and I maybe played a couple jokes once or twice. On the other end, you probably have something like secure multi-party computation or fully polymorphic encryption. And I think it's fair to say that the more secure your computation is, the less flexible it's going to be. And so over here in this world in grad school, I was able to pretty much do whatever I want with my data and anyone else's data. That was problematic. And then the techniques that are available through MPC or fully homomorphic encryption are just far more limited. So I think of trust execution environments as a little bit towards, not the middle, but it's closer to the more secure side, but it still enables a lot of flexibility. So for those who haven't been that exposed to it, essentially what you do is you partition off some of the memory to keep that secure during processing, and only approved code that is attested to can run. So that's what a trust execution environment is. Clean room is sort of a blanket term to refer to a lot of different technologies. But the basic idea is that 2 parties want to combine data, and they're going to rely on a trusted third party to help them combine that data. And so sometimes that looks like combining 2 databases in a technology like Snowflake, and then limiting the types of SQL that can run. Sometimes it looks more complicated. The data is ingested in memory, and you can run Python queries or other type of commands against it. And so when it comes to clean rooms, how secure the implementation is really depends on how the technologies are implemented. Okay, so that's sort of like the overview of all those vocabulary words. So what's great about both of those solutions? So both of them offer the ability for some form of code review. Both of them offer some form of flexible computation where you can use tools like differential privacy. And then with both of those, you could easily be able to run differentially private computation. So the pro to clean room is that type of solutions tends to be really approachable for analysts, and it allows for interactive queries. I think as we learned a little bit earlier, interactive queries have harder privacy guarantees. And so that's one of the downsides that come with it, is that in that framework, it is harder to ensure the privacy of any given output. And in fact, many companies have resorted to manually inspecting the queries that are run to make sure that they are sufficiently private. Trusted execution environments, on the other hand, it's far easier to ensure that you're deploying differential privacy correctly and that you're creating the privacy that you want. The downside to it is it's a harder solution to scale, and I think we might touch on this a little bit. There's no access to shared memory because you're trying to protect that memory during computation, and there's just like a higher burden or barrier to entry because it's not seamless to deploy code. We'll pause there.
Then we'll ask Andy Knox, who's a Centric, to
Sure, yeah, no, so one way I think about, like when I'm talking about DP to people who have some sense of it, you know, clean rooms and most of these other pets and differential privacy are sort of in different games. They're like complementary, but two sides of the same coin. I've had some people say like input security versus output privacy is one way people like to frame it, but that I think it's really important to like that distinction that like all of these secure multi-party computation and homomorphic encryption, those are going to give you a secure place to do stuff. It's basically like access control on steroids in a way of thinking about it, in terms of like you have really tight control over the authorized access of who can contribute data, who can take data out. But they don't really say anything about when you can infer from that authorized access, right? Like it's a really nice way to keep all those things tight so that you know exactly who's getting what. But you know, you can still do reconstruction attacks if the thing you're outputting allows reconstruction attacks. One other thing I did want to highlight a little bit about, like the intersection here, is trusted execution environments. All of them come with their own limitations, but you know, they bring new complications to the problem. So for instance, like in trusted execution environments, often time is not trusted. Like the way the hardware is put together, you don't have a trusted source of time, which sounds like a weird thing to say, but it means you don't necessarily know if you've been rolled back to a previous point in time, so you might not necessarily have a lot of confidence in what budget is remaining if it's been allocated over several things. So like there's some really, you know, if you can't guarantee what time it is, it's really hard to say if you spent your budget yet. So interesting problems that can arise just based on, you know, how locked down the system is, and that, you know, your clock is not within your trust barrier. That's a, you know, interesting thing. But I would say that like on the previous point, though, like there's sort of two things at the table, and I would think of the MPC and trusted execution, things like that, as like maybe complementary, but on the other side is more differential privacy versus pseudonymization and aggregation. And so I think that's really where the thing is like both, or you can only use one, but like it's a very common thing to see people who want to just like, let's do it in a clean room, and then we're just going to drop the email addresses and ship it. And so it really depends on how people think about privacy and what their obligations are.
You've got other pets that you'd like to bring to the table here?
Yeah, I think
What are your thoughts?
we touched on this a little bit earlier with Christine's community pitch. Synthetic data is an option that a lot of people choose when they don't want to necessarily change a lot of their tooling, and they just want data as the input to whatever the algorithms were. You know, maybe they wrote something and Python, they just want to have there be some sort of privacy available, and without changing their tables, without changing their actual like count algorithm, for example. So they might choose to use synthetic data, and that actually there's some great work that came out of the NIST challenge over the years, I guess, the multipleness challenges. And for tabular data, stochastic algorithms, some deep learning based, some not, some statistical. And the ones that actually are compatible with differential privacy and quite well actually tend to be the statistical ones. And it's quite exciting because you can get for a sort of, let's say, a limited data set with largely categorical values, you can get some pretty reasonable synthetic data out of that with differential privacy guarantees. So that's quite compatible, and we built that into the product at Brittle, and it's been very successful. It is one of our fastest models. It's, you don't have to train a GAN to get synthetic data. You just plug it into a statistical model. It's a few computations, you specify an epsilon of single digits, and you get good quality synthetic data that can be used for the majority of use cases that we've seen. And also having an epsilon attached to something is always great when people are looking for privacy, even if they don't know what it means. So that's one. Then this opens up also this can of worms that is, what are these models? They're all generative models. And when you hear generative models, well, now most people think like ChatGPT, right? So thinking like foundation models that can answer questions or that can tasks like question answering. And you want them to be honest, you want them to be truthful, you don't want them to hallucinate. And so there's a lot of open source work, and there are a lot of models that have been open source, closed source that you can use to accomplish these tasks. But often companies don't find sufficient value from just using a base model. And if they want to go open source, right? So let's say you're using Llama 2 and you want to do something that's very specific to an industry, it may not provide the best performance because it may not have seen that kind of data. So then your natural next step is fine tuning. So you might want to fine tune the weights of Llama 2 using whatever subset or whatever your industry data set is, your specific proprietary data set is. And then if you want to use that internally, maybe that's okay. But if you want to release those weights and perhaps, again, open source that, you might want to use differential privacy for that fine tuning process. And so even there, that is also compatible, but requires significant tuning. But there's some very helpful tips from the academic community on that. And a lot of folks in Google have published a lot of helpful tricks.
That's a good lead into Peter. You have other combinations of pets that you want to highlight. Do you want to talk about stuff in this space?
Yeah, I mean, I wanted to briefly say that our understanding of essentially how to combine differential privacy with classic multi-party computation protocol has evolved quite a bit over the past few years. We've seen a few deployments, including one at Google, but really a key to that was that we have a very good mathematical model on how crypto works, right? That's a mathematically inherently mathematical, it's a math concept. So we were able to combine it with DP properly. What I think is missing in the trusted execution environment space is that researchers like myself, who are not experts on hardware, would like to have some sort of a mathematical model for what that TEE is. I want to design an algorithm that's compatible with TEEs against threat models, let's say, for those types of technologies. And we don't have a very good understanding of, this is how you should think. This is an abstraction for what the TEE is, for the constraints, for the memory overhead, for the compute overhead. You should avoid doing such and such computations because they're very expensive to do in a TEE. So if we could bring in people with systems and hardware expertise and have them create an abstraction model for a TEE, that could help DP researchers identify new algorithms for that kind of an environment. And we could achieve some success like we did with MPC. And then we still don't know all the threat models. Like there's obviously, people talk about side channel attacks, but there's a lot more. We're moving the root of trust here to the hardware manufacturer. What does that really mean, et cetera? So there's a lot of interesting open questions. And I think over the next few years, we're going to see a lot of advances on this front. So I'm excited about that.
Could I add something really quick before we move on to the next topic? I was just going to try to, in the context of talking about multiple pets, I'd like to sort of reinforce a point. So I think Lipika mentioned that there's a need to have better explanations for like, what does epsilon equal 1 mean? And I think everybody kind of agrees with that, and there's a lot of attempts to attack that from different angles. I think it's really important that we start doing that in a specific context. So just at the simplest level, what epsilon equals 1 means if you're doing randomized response and attaching your outputs to like individuals is very different from what epsilon equals 1 means if you're doing, you know, Laplace mechanism, some type of output perturbation. And I think that that question becomes much more complicated and interesting and nuanced if we say, what does epsilon equals 1 mean if we're adding noise in this way in a trusted execution environment with this level of thresholding to make sure that there are a certain number of people in each bins, with all of these complicated context-specific things. And we sort of have our really clean, what does epsilon equals 1 mean in the worst case explanation. And so I think researchers can say, that's done. We know what epsilon equals 1 means. But what does it mean in specific contexts is something that I think is very relevant for these practical deployments.
Are you saying that as people are starting to explore and accept the idea of empirical privacy, that the pets that are in combination with DP influence what an empirical privacy guarantee is?
Yeah. And so I think empirical privacy can kind of mean like attack success probabilities and that type of thing. And I don't necessarily even mean that. I think what I mean is one of the beautiful things about what differential privacy is it's a definition, it's a property, not an algorithm. But I actually think that understanding what it means when attached to an algorithm is relevant. And I think that there could be more work done in that space.
Right. Okay, the last question, the one that we've sort of touched on, and a number of people here have comments on, and it's come up earlier and even in our original keynote, is that one deployment, one thing that stands in the way of DP deployments in practice is a lack of firm understanding, perhaps particularly when we communicate to higher ups in industry who are making choices about whether DP actually means privacy from a regulatory perspective. So the question I'm going to ask is does this lack of, if we don't have regulatory assurance that DP is privacy, when the law says privacy is necessary or ethics require us to make private choices, is that hindering industry adoption? And follow-on questions that you can pick up or not answer as you want would be, can industry adopt DP as a best practice without that kind of regulatory assurance that DP is privacy? Are there ways that researchers and other people in the room here and this community, as we evolve and push and try to bring ideas to the forefront of policymakers, can researchers help assure policymakers and regulators about what DP means and try to grow a consensus and try to grow some confidence foundation that will help DP adoption? That's the question. I'm going to start off with Andrew here.
Sure. So I'd say emphatically yes. Lack of regulatory assurance is a barrier. I think that's not surprising to anybody. One way I think about this is for a lot of organizations, privacy is a compliance issue, right? They're not necessarily competing on privacy. They don't care to show off they're the most private. It's a box they need to check. Like, private, it's compliant. I'm meeting my obligations, and so you know, because it's very binary like that, something like differential privacy that requires a lot more discussion can be seen as sort of like too complicated in the sense of like, for many of the things they do today, they've already had privacy requirements, and they're already doing something like aggregation or something like that. And so, and those existing methods are, they're well known, they're easy to implement, or seen as being easy to implement. They're seen as being easy to explain. Like if anybody ever did have a question about the compliance, they can easily explain, yes, we dropped this, we don't let this person access this, and we aggregate to this. Like it's seen as a very easy, common sense, straightforward way to do things, which, so, that's part of the barrier with the regulatory compliance thing is that the existing methods are seen as easy and they're just trying to be compliant, and they're not like going off with a little bit. One analogy that I love to make and thought about before is that privacy for a lot of organizations is like having a physical vault for a bank. Right, like banks need a really strong, secure physical vault to put, you know, safety deposit box things and cash and whatever in. But like banks aren't competing in market on how good their vault is. Or like Bank of America is not advertising, like we have the best vaults. Like it raises all sorts of questions in the consumer mind. Like, I need to be worried about how good your vault is, but like the point, like they need a good enough vault, that's not a question. Right? But they're not trying to like have a subtle conversation about how good their vault is. Like their vault engineers are, or whatever, but you know, like it's not something they compete on. So that's sort of the place that we're in. So it's so when you think about like with lack of regulatory assurance, you know, how can you go forward? And I'd say there's sort of two ways that I see, and one is to make it shown as being easier, right? So like actually a lot of these methods that are seen, they're sort of seen as being easy, like, oh yeah, I only let 2 people access it, I aggregate it up, you know, it actually may be a lot of work, and actually maybe there could be opportunities for DP to do a better job there of being like actually easier to deploy or easier to maintain. And another one that I think is another really good opportunity is areas where the utility is not high enough, right? And so these can actually be very hard to find because if the utility of the current existing practices isn't high enough, maybe they didn't do them in the first place. So you know, the use case doesn't exist. So there would be like a lot of existing use cases with their existing privacy mechanisms, but you know, maybe there was some use cases they had where like, you know, the counts were too small, or it couldn't get you couldn't get enough utility to make it worth it, so they never did it. And so hunting for those use cases where by doing a differentially private thing, all of a sudden they can open new doors is like a path forward without regulatory assurance that that could help people. And I think that's that's one thing. And one other point that I forgot is the idea of non-compliance use cases, right? So for a lot of people, like privacy is compliance, but of course there's lots of cases in lots of industries where privacy is real. So in terms of like, it is part of their competition and so forth. And I would say this is like things where it's about competitive advantage. So I've done a lot of work in the ad space, and so like there are a lot of situations where you want to collaborate with data with somebody who may be like a frenemy situation, and you want to get a certain amount of analytics, but you want to make sure they didn't use it for something else. And so that touches on other pets, but also like from a privacy point of view, like if the reason you're trying to protect your privacy is to preserve your competitive advantage, then I think you're prepared to be very subtle about your risk tolerance, as opposed to compliance, which is probably a little bit more like, are we at risk or are we not?
Things you want to say?
Yeah, I mean, of course, I would love if there was regulatory assurance about differential privacy, but when I was thinking about this question, I kind of feel like we encounter data custodians who are working under some vague regulation that they're trying to abide by, but they've often already gotten weaker privacy mechanisms, you know, approved, and they're in use. But we see those people as getting increasingly nervous about the effectiveness of that. And DP, I think, is already recognized as you know, one of the strongest things you can move to. So I think even without regulatory assurance blessing DP, one of the things that can really push people to DP is regulation casting doubt on weaker methods. I think that can be a very effective tool in convincing people to move to stronger methods.
Yeah, so maybe slightly more optimistically, I think alignment around DP is happening in pockets of industry, even without that regulation. So 2 weeks ago, I guess maybe for context, I spent the last decade working in ad tech as well. 2 weeks ago, I was at the organizing conference for the W3C. So you can think of that as they create standards for how browsers operate, including things like third-party cookies and what data can be shared. And so the group I work with there is trying to understand how can we enable algorithms to understand if ads are effective or not without sharing data between these companies. And it seemed like a foregone conclusion that differential privacy is absolutely part of the solution. Like there is no debate about it. The strong debate actually was more on the secure computation side. Like what are the restrictions we're going to place on computation? I will add, however, despite everyone saying like, yes, it's gonna be differentially private, to the point earlier, there was a discussion, and I'm not gonna name which major tech companies were there, but you can think this is an organization of people who operate browsers, debating, debating what epsilon value should be. And without necessarily realizing that they all had different proposals with different privacy semantics and privacy units and different considerations of time. So just to reiterate the earlier point, it's not really sufficient to talk about epsilon because it needs to be considered in context. And so while we are aligned, at least in that pocket of the industry, that differential privacy is a solution, I don't think there's any alignment on how you determine the context and how it's applied.
Are there any follow-ons on this question? Yes. Okay. Thanks. If there are questions, so.
Thanks for an amazing, thought-provoking panel. Could any of you comment? I'm curious. Are there industries which seem to you to be where DP seems to be really a good fit for some set of problems they have, and you know what's needed is either the pressure from the right places or awareness or getting people past the, you know, their whatever entrenched practices. You mentioned ad tech as one where this like DP is going to be, seems like it's on its way to making its way into that. What other examples are there?
I think another example is finance, in particular, like data markets around financial data, I think are a good fit because fundamentally the value in the data is aggregate in nature because it's about trends of what a lot of people are doing, you know, through credit card transactions or trading flow data. So I think in principle that is a good use case for differential privacy. And what's needed, yeah, I don't know, the typical stuff. People are increasingly nervous about legacy techniques. I think, you know, maybe a motivator there would be that actually, I think, and I was trying to get at this in the last point, but like sometimes when people adopt these weaker privacy techniques, they actually publish less data. I mean, maybe that's not a huge surprise to everyone here, but you have to take an extremely conservative stance, and you often keep a lot of data back. So if they start to see differential privacy as a method by which they could sell more data, I think it could be powerful, just basically.
I wanted to also add that geo applications are also an extremely good fit for DP. Often we want to do things like heat maps to see in what environments or communities diseases are spreading, or mobility reports to see where people tend to be concentrated, where there's congestion, things like that. So these kinds of very high dimensional type distributions are, again, aggregate in nature, and DP seems to be a very good fit because we want to share this with the public and act on it.
Other questions?
Might be one online.
Oh, okay.
You want to call them out?
What is it?
It's a meeting room.
Okay. There might be one online. While I'm, no, I don't.
Well, no,
Oh.
just say, this,
Oh,
Lisa,
somebody's raised
Lisa
their hand.
needs braces. You have a question.
The old-fashioned way.
Yes, Lisa, possibly Lisa. Or someone who raised hand still has a question.
It's a Simpsons
Do I have
themed
to
room.
unmute? Ask them. So
The hand has
also,
been up since the beginning of the panel, so I think it's.
Yeah.
okay, thanks. So if you do have other questions, some of our panelists are here today, and it's the best way to talk to you. Okay. There is the Slack channel if you want to follow up, and please take a look at the biographies. There's also projects that some of the people here, panelists have highlighted projects that they are interested in promoting or engaging with researchers on, and part of the reason of having this is not just to sort of indoctrinate you all in how hard it is to translate your work into practice, but also, you know, the shared goal of OpenDP and its mission is to bring about these social benefits, to see implementations that increase the social good. And that means solving these problems and trying to get deployments in practice. So people who are interested in these problems, or interested in engaging, and how do you make the library work in a way that makes it easy to deploy, makes it easy to stand up, makes it easy for people to be assured that their answer is DP and it meets the privacy promises that they're expecting. If you're interested in those problems, that is a focus of the OpenDP community, increasingly in the next year's problems. I hope this is kicking the butt to be involved in those things too. Thank you. Thanks everybody for their time, and